Okay. Question 43 from chapter 10. We're finally on the last question. This is a very similar question to the one before, except there's a few complexities in it. I'm only going to do the first one in this case because these are rinse, wash, repeat things. So like it's just repeated application of the same sorts of formulaic things. So as I offered with all the other questions I only did partially. If you have questions about the results of the other bits, you're welcome to email me. You're more than welcome to email me. Okay, so again, this always starts with the Lewis structure, right? Especially if it's one that I don't know. Okay, so this is going to be 5 times 8 for the amount of electrons we need, minus, we have 4 times 7 from the fluorine makes 28, plus 6 from the sulfur makes 34. So we have 34 on 2 is 6 over 2 gives 3 bonds. That's interesting. We got 4 ligands and 3 bonds calculated, so you know this is going to be a juicy one. All right, well, anyways, that didn't tell us anything really except that this is going to be interesting. All right, so let's add some fluorines and let's just see what happens here. Okay, whoops. There we go. Okay, these are definitely going to need some of these. All right, hopefully we don't run over our quota here. Okay, so 34 is an odd number. This is a strange number when you have 4 ligands around a central molecule, right? So you should see that already. So this is because this is 8, like 2, 4, 6, 8 electrons. 8 plus 8 plus 8 plus 8 means we have 32, but we need 34. So that means we need a pair on sulfur as well. That is interesting, right? So that means that that our central atom in this case has 4 ligands. 4 ligands. And 1 free pair, right? This corresponds to an sp3d hybridization. Hybridization, right? So Hib for short. Okay, we'll do molecular and electronic geometry in this case because the electronic geometry kind of makes this make more sense. We would expect. Let's do the electronic first. So fluorine. This is the area where the lone pair can get the most space. So we'll stick that there. Wouldn't really matter where. You're just like you're flipping the thing n for n for n no matter where it goes, right? So that's the electronic geometry. So the electronic in this case would be equal to trigonal bipyramidal, I think is what you'd call that. Trigonal bipyramidal. All right, so you get the triangular pyramid there and there. Now, for the molecular one, where we're not counting this one at all here, I actually had to look it up. I wasn't sure what you're supposed to call that. Structure, and it turns out they call it a seesaw. I guess the idea being that this is the little brace here, and then you have a long straight piece that's supposed to wobble from side to side, I suppose. But anyway, so if you have sp3d hybridization with 1 free pair, just remember that you call that a seesaw, your resulting molecular geometry. It's your interesting tidbit for the day. All right, everyone. Good luck on your exams. Good luck on the exam prep for chemistry. Feel free to email me if you have any other questions. Otherwise, we will talk to you in the new year. Bye-bye.